Hello, geometry. Today we're taking notes on section 8.3, rectangles. So we're diving into our quadrilaterals focus today. Well, I guess building off of parallelograms yesterday. So first off, the properties of rectangles. Rectangles have the same properties as parallelograms. So they have opposite sides congruent, opposite sides parallel, opposite angles are congruent. Consecutive angles are supplementary. So the ones that share a side and are in between the parallels, those ones are supplementary. Diagonals bisect each other, so diagonals are equal. And then they have two extra properties. All four angles are right angles. So in the picture below, for example, we have a right angle here, and on each other corner. And then also the diagonals are congruent. So the diagonals bisect each other and then they are the same. So they are the congruent. So like I said, we've got a right angle in each corner as well. So here's the new one. We've got right angles at each corner. And the diagonals are congruent. So pretend this is a straight line, boom. Not only do these meet in the middle of each line, but these lines are the same length. Okay, so we're going to dive into solving using these properties. So example number 1, each quadrilateral below is a rectangle. Find the missing measures. So they give us, well, PS is 10 and PQ is 24 units. So first off, we want to find QR. Well, QR is opposite sides of 10. So PS. So it is also 10 units long. There we go. 10. SR is going to be the same as what it's across from, PQ, which is 24. Now SQ is the diagonal, and it's specifically this diagonal right here. So notice, we said this is a rectangle. Well, if I'm looking at that top triangle that's now formed, we have a right angle here. One side's 24, one side's 10. So because of that, we can use Pythagorean theorem because we have a right angle and we know two sides. So we can call SQ X. Let me see if I can move that. There we go. So we can call SQ X. And we can say, well, SQ is really 10 squared plus 24 squared, which equals the diagonal squared. So we're using Pythagorean theorem. A squared plus B squared equals C squared. Remember, C, or the thing by itself, is always the hypotenuse, what's across from the right angle. So in this case, we don't know what that value is, so it's X. Okay, so to solve using Pythagorean theorem, we take 10 squared, we get 100. 24 squared is 576. Add those together because they're on the same side, we get 676 equals X squared. So X squared is not X by itself. To get rid of that squared, we take the square root of both sides. So really we're undoing the squared. And when we take the square root of 676, we get X equals 26. So side SQ is X. We didn't know what it was, we called it the variable. So side SQ is 26 units. Okay, we're going to finish that up. So SQ is the diagonal. It is 26. PR is the other diagonal, which our new property says that the diagonals are equal or the same. So it is also 26. QT is only this piece of the diagonal. Well, just like parallelograms, the diagonals bisect each other. So it's the same on both sides. So if the diagonal is 26, well, if it's the same on both sides, we're really taking 26 divided by 2. QT is 13 units long. Alrighty, moving on. Number 2. This time you're going to notice we have angles involved, and that's all we're solving for is angles. Angle MJK. MJK is the whole angle, and because it's the whole corner angle of the rectangle, it is 90 degrees. MJL, well, MJL, let me change colors, is really this angle right here, just the bottom half. If we know the right side's 27, the whole thing's 90, we can take 90 minus 27, and we're left with 63 degrees. So angle MJL is 63 degrees. Angle JLK, well, that's really this angle here, JLK. It is, let's see if I can get that all the way over. Let's try that again. There we go. JLK. Well, it is really alternate interior angles with our 63 degrees. If they're alternate interiors, they are the same. So it's also 63 degrees. Now KML. KML is really, let me get a new color. KML is right here. That's what we're wanting to find. Well, currently, that angle is in this bottom triangle. And because the diagonals bisect each other, and they're the same, really these pieces are all the same. So that bottom triangle I'm highlighting, MNL, triangle MNL, is an isosceles triangle. So if angle MNL, triangle MNL is an isosceles triangle, then angle KML is a base angle, and so is JLM. So these angles are going to be the same. Okay, well, if this angle MLJ, that second one I marked, the second purple angle, well, it's alternate interiors with 27 degrees. So that angle's 27 degrees, and we said it's a base angle. It's the same as angle KML, 27 degrees. Okay, lastly, oops, let me find a different color. Okay, lastly, angle MNL, right here in that top. MNL. Well, like we said, this is an isosceles triangle. We know the bases are 27 degrees. So 27 plus 27, that's 54 degrees. Total used. We don't know that green angle, but we know in a triangle, they add to equal 180. So 180 minus 54, that really gives us 126 degrees for angle MNL. So you're going to get creative. You're going to need your tick marks, your curves, maybe even a color could be helpful like I'm using, but you're going to need to be marking up this picture. Angles are going to be tricky. Remember, alternate interiors. And then inside of a rectangle, we always have isosceles triangles, and that's both the bottom and top. Those triangles are going to be the same, and the side triangles as well, just for future note. Okay. So now moving on to number 3. Example number 3. Given side DB, actually the diagonal D to B is 42 units. And they give us side AD is 26. Sorry, that side AD is 26. Let's try that a little nicer, sorry. 26. Sorry, I'm using my finger. That's as nice as it's getting. And they tell us angle DAE is 52 degrees. So there's our 52 degrees. Okay, find all the missing measures. So for starters, well, AC is what we want to know first. Well, that's another diagonal. The diagonals are congruent or the same, so it's also 42 units. Now, section EB, segment EB, is the same as segment DE. We know the whole diagonal is 42 units. So to find EB, we take 42 and divide by 2, because it's the same on both sides. So really, EB is 21 units. BC is across from AD. So it's going to be the same. They're across, they are congruent. So it's also 26 units. Now, to find AB, we do not know a side AB. So we can look at either triangle. So if I'm looking at this top one, for example, I know AD is 26. We don't know the top side AB, so that's going to be our variable. I'm going to call it X. this is a right triangle because it's a rectangle. And we do know the hypotenuse. The hypotenuse is dB, or 42 units. So again, to find the third missing side in a right triangle, we're going to be using Pythagorean theorem. AB is really x squared plus 26 squared. The leg plus squared plus the other leg squared equals the hypotenuse, which in this case is 42. So when we square 26, we get 676 plus x squared. On the other side, we get 42 squared is 1,764. We subtract 676 to both sides, and we end up with 1,088. Now, final step, take the square root of 1,088, and we end up with 33.0. That's rounding to the tenths place, because I believe it's 32.9, I think it's 8 off the top of my head. And when we round up, well, that makes it a whole number. Don't forget your 0.0, because we did round. So make sure you're rounding properly. It does not tell us to round to. I like to round to the tenths. Tenths or hundredths is really what I'll be looking for. Okay. To finish up, we need to talk about angles. So I'm going to clean up our picture a little bit since now we're moving on to angles. We might not need all these tick marks. Might help us a little bit. All right. So we do know the one angle, DAE, right here, is 52 degrees. 52. Okay, our first goal is to find angle ADC. Since that is the whole bottom left corner of the rectangle, it is 90 degrees. Each corner in the rectangle is 90. Now, angle ABD. ABD is right here. This is a new triangle on a different side, so we do not know this one off the top of our head, so it's going to take a little bit of work. We know this angle 52 degrees, though. Its alternate interior would be angle BCE. So that angle is also 52. Now remember, because the diagonals bisect each other, we've actually created isosceles triangles. So if I know BCE, angle BCE is 52 degrees, well, so is angle EBC, right here. That is also 52 degrees. So to find the angle we want, ABD, all we have to do is take 90, the whole angle, a right angle, minus 52. And that will tell us that angle ABD is 38 degrees. Okay, moving on, we're trying to find BCA. Oh, we actually just used that angle. BCE is the same as BCA. Well, we gave it two curves, just like we gave the angle they gave us. So this one is also 52 degrees. It's part of that isosceles triangle on the right side we just looked at. Lastly, I'll use a new color to really make it stand out. Angle DEC. So we're looking at this bottom middle isosceles triangle. Okay, we know that this angle here is 52 degrees. So that means that angle DCA is whatever 90 minus 52 is. And we said that this is 38 degrees. So I'm going to mark that right there. That is 38 degrees. Because these triangles are isosceles, so is this angle, 38 degrees. So to find the angle we want, angle DEC, we add those together, and we get 76. Take 180 minus 76, minus the two angles we know, and we get 104 degrees for angle DEC. Rectangles give us a lot of information if we're looking for it. So that's how to find different pieces, multiple pieces. Now we're going to be looking specifically at different parts and what they're asking for. So in number 4, they give us the rectangle, and looking at the picture, they give us CD and EF. Since they are across from each other, they are sides that are going to be equal. So I set those pieces equal. 3x plus 5 equals 7x minus 39. I move the x's to the same side by subtracting 3x. Then I add 39 to both sides, and we get 44 equals 4x. Lastly, to get x by itself, divide by 4.